Hi, welcome back to the Gabster channel. This is an exciting one. Again, we're going to show you today how step by step to build this Gabster TD1 Dac and based on the IanCanada Streamer below it. In the first video, I'm going to talk about how to build the Gabster TD1 Dac from starting from the streamer up. And I'm going to make another video where I'm going to talk about all the parts you need to build the streamer part. So at the end, you can build the whole thing and you know step by step exactly which part you need and how to build it. First, some quick good news is I've managed to ship all the boards to everyone that actually have purchased the boards. And they're all being shipped. Some of people have already received them and some are just coming. I just shipped a whole bunch just yesterday, so give them a good week or two to get to your place. Depends on how far you are. Some places it's going to take a long time. If you live in some far away remote area in the world, it's going to take a long time to get to you. But if you're really close, it's going to come fairly fast. People have ordered kits. I'm still waiting on some parts to add to the kit, so it's going to take another probably 2 to 4 weeks before I can even ship those. And people have ordered assembled units. These are going to take anywhere between 2 to 6 to 8 weeks to get them. So just bear in mind that I'll try my best to get those done. I have emailed every one of you about the build of material and the code to access the Mother parts. Also, they come with the kit as well. The code comes with the kit as well. So if you have not received that email, please check your spam email, because a lot of times those group emails end up in the junk folder. So check in there and there should be an email about how to access the build of material and also the code for the to get the Mauser parts ordered with a couple clicks of a button. If you have not received that email, you can send me an email and I'll gladly send you another copy. All right, let's get to it and start building the Gabster TD1 Dac. All right, so let's start adding the Gabster TD1 Dac. We've already built our streamer. If you haven't seen this video, I'll put a link of it below and in the corner. And so you got to the streamer stage. Now we're going to grab one of our Gabster TD1 shields, and we are going to install on it 4 standoffs. These are up to 6 millimeter standoffs, and you secure them with a nut underneath. So just like the way you see it here. And you also need to put another 4 on the far corners here, and these are going to be 20 millimeter standoffs. If you don't have 20, just use what I'm using here. These are 2 10s stacked on top of each other. So basically, you put 1 in each corner, and you use a little nut on the back, and that's how you do it. We're going to do 1, 2, 3, and 4. And this is the last one here. Make sure you tighten those. Now the holes on the shields are meant to accommodate 2.5 and 3 millimeter shields. So sometimes if things are not jiving well, you can loosen them up and move them a little bit. There's a little bit of wiggle room in there. So once you have all your standoffs, your 6 millimeter shields here on the PCM board side, and your main basically 4 standoffs of 20 millimeters each, you're ready basically to install this on top of your streamer just like that. But before we put it on, we are going to run the UFL connectors. So we're going to turn this around, and just to show you that on the FIFO-Q7 card, there are 4 UFL connectors. And we are going to use 4 UFL cables. These are basically 10 centimeters each. I'll put a link of all these in the description. And what you're going to do is just put 1 on each UFL connector. Just make sure it's completely there, and you should hear a click and you should see it turning and being stable. So you're going to do that on all 4 of them. Just make sure you don't put it the wrong, like don't force it. Once it's in the right place, it should go on. Sometimes they don't click, and but they'll just fall into place. I've got the last one here, and you should see they're all properly secured. Now you are ready to put in your shield on top. So what you want to do is there's about 4 holes here that are made specifically for routing the UFL cables. So basically you route them. I suggest you route them in the same order, because then you know which one is which on top. You don't have to keep looking around to see which one is which, because then you know the sequence on the bottom. And here's the fourth one. Now you might want to also note, I would probably grab a piece of pen and write down the sequence of these UFL connectors. So then I would write on the piece of paper, master clock, SDD1, LRDO, SCK. Just write them down so you know which one is which. Once you've done that, you're ready to put in the shield. And this is going to go just like that. And you've got your 4 UFL connectors coming out. The reason I gave you guys an extra shield, and for the people that bought first, there's no charge for that, is I wanted to isolate from the clocks, and then I want to put my PCM board here, and then I want to put another shield and isolate from that as well. So when it comes to the Gabster TD1 Dac that goes on top, it's going to be perfectly shielded. Once you have your shield in place, you're going to put 4 little nuts on top to secure the shield into place. Next, you're going to grab your I2S to PCM converter card. And what you want to do, you will notice that this card does not come with UFL soldered to it. There's a lot of them. There is a way you can actually use the wires, but it's not the best way. Using UFL is probably better. But if you cannot solder too much the UFL connectors, then you might be, an option would be to use the cables that came with it. But I'm going to just show you how to solder those UFL connectors. And the main thing about them is that they have 4 sides, and 3 sides are negative and 1 side is positive. And it's important to make sure they're oriented in the right place, because otherwise you're going to short the UFL, you could short your board. It's important after you solder them to test and make sure that they are connected properly before you do anything else. If anything is going to go wrong, it's going to be putting those UFL connectors either on the PCM I2S to PCM converter, or putting those UFL connectors on the Gabster TD1 board. So just make sure you get those in really nice, that they are connected properly. Soldering those little UFL connectors onto the PCM board is pretty much the same as soldering them on the Gabster TD1 Dac. So I'm just going to put some clippets from that video to show you how to do it. This is a very critical part, and it's a little bit tedious, and it's important to do it right so you don't mess up the whole project. The UFL connectors from Mauser are actually even harder to discern where is positive, where is negative. If you see where the arrow is, you could see that the square kind of rounds up a little bit. That's the side where it's positive. That tiny little one is the positive. All the other 3 are actually negative. So you want to make sure that that positive is on the positive pin on the board and not any of the other way around. Any rotation will basically, you're shorting positive to negative. Here you can see on the data sheet that where the positive pin is, and that all the other 3 are actually ground, and the little dotted mark, you can see the layout of the actual UFL connector. You turn it in the way you don't overturn it, because it's easy to mix things up. You can also hold it like this and just have a look, and just make sure you've got it in the right orientation. Here we go. The easiest thing to start is by soldering the ground. So we are going to do that. So what you want to do, the reason I left the pads a little bit bigger, because you could start soldering on the edge here without disturbing the UFL connector, and let this solder just flow underneath it on its own. There we go. So now it moved a little bit on me, so now what, it's kind of somewhat secure. I'm gonna put my tweezers in the middle of it, a little bit more to the center. It's important to use a very fine tip iron to avoid spreading solder on the actual UFL itself. Now I am going to connect some solder on the other side of the ground. It just flows underneath it. There we go. And the third thing we're going to do is connect the center pin. And for that, we're just going to just let it flow, and that should be good. Now with these, I strongly urge you to double check your connection, because it is possible that it is not, something didn't go well, so let's double check. So I put my tester on continuity mode. There you go, you can hear it. When there is connection, it'll beep. And we know that this should be the center right here. So now we touch the center, and it beep, and that's good. Make sure you use a magnifier to figure out where the square rounds off, so you can figure out which side is a positive. So if you look at this diagram here, you can see that that's the side where the positive is. And here they are on top, and on the bottom, don't forget there are 3 on the front part, and there's 2 on the very top corner, so 5 in total on the bottom. The 2 on top you will need if you're going to be running a balanced mode. So once you have your UFL connectors in place, you're going to connect the 4 UFL cables. So the first one is SCK. So SCK is the same here. It says SCK, so it's easy one to figure out. So just then we're going to line it up properly. Sometimes you just have to twist them to get them in the right orientation first. Make sure it's exactly on the center. And just press a little bit, and there we go, you can hear the click. So the second one is LR. So LR, sometimes they call it LRCK, sometimes they call it WS. These are the same thing, different names for the similar thing. So that's going to be the second one. So the second one is the LR. It's going to go where the WS is. The third one is SD or D1, also called data, and we're going to put that on the SD. Just a little bit so it's in the proper orientation, line it up properly, push on it, and just wiggle back and forth. Here you go, and it's in. So we've got those 3 into place. So once those are into place, we can flip this around, and this is going to go actually here, and we just push those cables down a little bit. The master clock connects on top of the board, so you make sure you stretch it as much as you have allowed. It's going to be just tight, but it will fit. Now what you're going to do is you're going to put 4 little screws here to secure the board. Now we've got all 4 screws in place. Now there's one still, the master clock. What you want to do with the master clock, you're going to find it on the bottom and find it's the first one towards this side. So it's this one here. You're going to, what you want to do is just give it a little bit of wiggle room, just so at the end it's got as much room as possible. And you're going to bring it on, it goes on top, and it's going to go into the master clock here. We're trying to keep all the UFL connectors the same length. It's important when you're at such high frequencies, the length of your cable could affect the skew of the frequencies. So now we've got all 4 UFL connectors connected from the FIFO-Q7 to the I2S to PCM converter board. So the next thing we're going to do is supply power to this board, and this board runs on 5 volt. So there is actually an input here, DC input. So we are going to connect this from here, just like that. And this is going to give us 5 volt to that card. To get 5 volt, we're in luck. We still have a 5 volt outlet here that's coming from the Ropieee. So all we have to do is run this cable here, and probably from this angle, and connect it to the board in here. So what we're going to do is get rid of this particular connector and strip those 2 wires and supply plus and 5. Make sure you get the plus correctly. So the plus is on the outer part of the board here in this case, and the ground. Otherwise you will fry this board here. So the easiest way to pull the connector from this thing is there's a couple little plastic tabs here. Just use your pointy basically tweezers and just lift them up just like that, and lift them up a little bit, and when you lift them up, these should just pull right out just like that. And this way it's kind of nice. Now with a long flat screwdriver like this, it's good to have those. They're great for actually poking around to remove the TDA chip off the board if you're replacing them. And they come in handy for all sorts of things. For example, you're going to screw in your power supply here. So we're going to basically loosen up those guys. And the ground goes on the very first one. So just loosen up all the way, make sure it goes all the way in, and just tighten that. And the 5 volt goes on the outer part. Just make sure you read, don't just go by that. Make sure it says 5 volts. It's a good habit to get into to avoid any mishaps. Just going to hold it with a little pliers here. Just going to make sure it's pushed in all the way. There we go. And then we're going to tighten up. So now we'll make sure these are nice and secure. Make sure double check again. It says +5. This is the red. Ground is the black. And that's we're going to double check all these, because one little mistake like that could cost you dearly. So here we go. We have our S2PCM card installed and powered. Now, so the next part is we're going to use a second shield, and that's why I gave you guys an extra shield, is so we can actually isolate from each other from the bottom here. And there's just double check that there's enough clearance, that we don't have anything touching. And if you use the right height of the standoffs that I talked about, you should be just fine. Now that we have the I2S to PCM converter in place, we're going to get 4 more UFL connectors, another 10 centimeter ones. And make sure that they're all the same length. It's very important not to mix like 10 and 15 centimeter. And you are going to connect 4 UFL connectors to CLK, LLR, data right, and data left. So basically DR, DL, LLR, and CLK. So just like that, you grab first UFL connector, you line it up with the DR, for example, push on it, twist on it a little bit, and it should, there you go, lock into place. First time you do them, they're a bit firm, so they're a little bit hard, but they do go in, especially if you line them up properly. Don't push hard if they're not lined up properly. So I'm going to do that for the other 4, so DR, DL, LLR, and CLK. Again, I wrote down the sequence of them, so DR, DL, LLR, and CLK, so I know which one is which. And another way, which is even better if you have time, is just wrap a little piece of green tape on each one of them, and you could write with a piece of paper what it is. So here you can see I labeled them DL, DR, LR, and CK. This way I know which one it is. So either that or a method of writing them down, which one you feel comfortable with. So the next thing we're going to do is going to add the second shield. It's important that the second shield is in the same orientation, because if you put it like this, it's just not going to jive well. So you can tell. And so then we're going to add, so the next shield with 15 millimeter standoffs. And so usually I put them in just to make sure they're getting in. And once they're in properly, I can go ahead and tighten all of them down. There you go. Now finally, for the exciting part, we're going to grab our Gabster TD1 and Dac, and we're going to install it on top. Now we're going to make sure before we install the TD1 Dac on top that the following jumpers are in the right place. So we're going to make sure that J3 GRD is actually, you have an actual jumper cover cap on it, and also J4. So J3, J4 has to have jumpers on them, and that J5 is on the OB and -5. So it says mode here. You're going to make sure that this is on OB and -5 area. So basically the last two here on top. So you're going to put your jumper right there. So make sure that that jumper is there. On the front, all the jumpers should be on, every one of them. So if you have one missing, make sure they're all in place. Notably, you'll see here that this jumper here, J11, J10, J21, J20, and we have here, this is J1 and J2 all in place, and J6 and J7 also all in place. So basically all the jumpers should be in. Once you double check all the jumpers are in, and also on the back, make sure you did not install the DEM capacitor. In this mode, we do not need the DEM capacitor because we are running the DEM on tied to the I2S signal, which is my preferred method. So make sure there is no DEM capacitor. If you solder it by mistake, take it out. And also that the J24 here is not installed. Basically, pin 2 and 4 are not shorted, so this should not be in place. Once you verify all this, you are ready to actually put your Gabster TD1 Dac on top of everything. So you're going to put it right there. And what you're going to do, you're going to put 4 screws to secure the board on the jumper pins. And one last screw right here, and we've got the board in the right place. So now we're going to put those UFL connector. So we are going to go and do one at a time. So we're going to grab, we'll start with here. It says here data right, so we're going to get DR. So that's DR. Now we're going to put it right in here. So that's where DR goes. Data right, then data left. Again, it's important to line them up. If you don't line them up, they don't go down. Here we go, data left. Then we have CK, so SCK, same thing. That's in, and the left one is LR or LRCX is also the same thing. And that's going to go right here. And there we go. So make sure these are all the same length wires. We've got all 4 connected. And you're pretty much ready to power the Gabster TD1 Dac. So far, everything is being powered by the PurePi, which is an excellent way to power pretty much everything. So the only thing we have left to power is the Dac itself. So here you go, you've got it all finished and ready to go. And I'm going to talk about the different jumpers and different configurations that you can do with this thing in a separate video. But I want you all to try this mode if you can. This is like where the holy grail of sound is, in RCA mode. And then we're going to talk about different modes, about balanced and all that kind of stuff, and how to run it with the capacitor DM. We can also going to talk about how to run it without the PCM board for those who do not want to spend money and get a PCM board, because you can still get a very good sound without the PCM board. It's also fairly good. Not as good as with it, but close. Also, we will talk about how you can even, the way the shields are designed, you can add copper like plates on the sides. You can actually fully encase this if you want. And there's different ways to use those shields. We'll talk about that one day. in the future. Now, some option to power this thing. Let's first analyze what do we need. So you'll see here there's a plus 15 volt and 0, so we need a 15 volt power supply. Please do not inverse or reverse these. So plus 15 is plus 15. And then a separate supply is going to be plus 5, 0, and minus 5 volt. So we need two power supplies to do this. So let's explore our options, what we can use to power it with. So if you are a beginner and you've never soldered anything, you've never tinkered with any DIY stuff, and you're really trying to build something like this, you're way over your head. But let's say you still want to go ahead and do it. I strongly don't want you to go and start using ultra capacitors and burn your house. So you can use a simple solution is to use some I-Fi power supplies. They are not linear, but they're very good quality power supply. They're very low ripple, and they're fairly decent for the price, and they're simple to use. So for the 5 volt here, that's going to supply your stack, basically your pure pi, one 5 volt power supply like these is all you need, and you're going to power the bottom part very easily, because remember, those are running on batteries and ultra capacitors below. And what you can do with the two of them, you can connect them in this particular configuration where you're going to get now 0, plus 5, and minus 5 volt. And for the 15 volt, you just get a third one, and you can get those in 15 volt configuration, and you can connect that to the 15 volt. What you might want to do is cut the wire and strip the positive and negative and solder it to the plus and 0 volt on the back. So that's option 1. Option 2, a step above that, is you can get an adapter. It comes with the I-Fi. They give you tons of adapters. So you're going to put your USB-C adapter this time. And what you're going to do is you're going to plug that into your input of a UC conditioner. And what this thing does is actually stores quite a bit of power in it, and it makes it much better, more stable power and less ripple into the current. And same thing, you're going to get 5 volt coming out of this terminals here. Just remember there's an input and output, so make sure you take it from the output part. So the input is your I-Fi going in, and the output is going to be coming from those two here. So you're going to do that twice. You're going to get a second one, and the second I-Fi goes into here. These are 5 volt. Make sure your I-Fi is 5 volt. And now you get two 5 volts, and it's the same thing. Let's check out this diagram here and just cross the wires to make 0, plus 5, and minus 5 volt. And a step above that, and this is using IanCanada's linear pi. They come in a dual configuration. What this thing does is you take AC voltage, and from here you actually convert it into a nice 5 volt DC as well. A step above that, again, same thing. You're going to mount these on top and get yourself even a more stable current. I made a video just on those combination. I'll put a link of it below if you want to know all the little nitty-gritties and the details on how to connect things. So I'm not going to go through here because there is a video just about that. So that would be the intermediate level. For the 15 volt, I would still probably use the I-Fi 15 volt, or you can get yourself a nice linear pi from somewhere for 15 volt linear pi and connect it. And this way you're not messing up with big ultra capacitors and taking chances. Now, if you are advanced, and I know we all want to call ourselves advanced and start playing with ultra capacitor, but there's a big warning here. Ultra capacitors could be very dangerous. They're not going to electrocute you, but they could cause some big, huge shorts, melt wires, fires, flames, explosions, things like that. So you want to make sure you know what you're doing if you are going to be working with ultra capacitors. These things are enormous. They can hold so much power. Now, if you are going to still go ahead and work with ultra capacitors, yes, you will get the best sound possible. but you have to know what you're doing, like I said. So I made a couple videos on how to use the +5, 0, and -5 using IanCanada's UC Pure Mark III. And these are excellent boards that helps you control the power of the ultra capacitors. Also, they have a feature where you can charge between songs. That's important to keep the voltage steady. And we'll get to that one day, why it's important to have a steady voltage. And so I made two videos, one about +5, 0, and -5, and one about 15 volt. You can also do a huge 15 volt and have 6 ultra capacitors. I find it a little bit too much because we only need such a small little amount of little power here, and just that little one, that I made the video about, it will do actually, and save you from having to have a huge, big ultra capacitor bank. So I strongly suggest you watch these videos if you are going to use them and you don't know how to use ultra capacitors, because there's lots of safety tips in there. And again, I'm not guarantee you are not going to burn your house even if you follow my safety tips. There's so many things that go wrong. So play with ultra capacitors at your own risk. To measure the DC offset, I suggest you put your probes one on each side. So you put negative on one side and the positive that you want to adjust. And that's the best way, because if you're trying to put them beside each other, it's going to be tight and it's hard to put the two probes together. I suggest you power your streamer first and just play a song, and just any song, just play something and make sure it's displaying that there's something going on. And this is when you can actually turn the DAC power on. So I just turned the DAC power on, and you right away see that there's some fluctuation, but that's because the song is playing and it's going up and down a little bit. So now you're going to pause your music, and that should steady up. And this is when you can adjust the voltage. So because the positive is on this side, we're going to trim this side first. Now small amounts like this I wouldn't worry about, but I'm just showing you how to adjust it. It can go anywhere between plus and minus 2 volts, so just to bear in mind. So right now we are 11 millivolts. That's basically nothing, but we're still going to move it down. Here we go. And that's close enough, 0.2 millivolts, that's basically nothing. Anyway, if you just have 100 millivolts, don't worry about it. Most amplifier, like I said, can handle DC, it's no problem. I mean, it's not desirable, but it's not like they're gonna kill your amplifier. As long as it's not above 2 or 3 volts, you should be okay. It's not gonna kill it, because even when you have music, it goes fluctuates on plus and minus 2 volts. But we'd like to keep it as 0 as possible. So set it to 0, and then you can always, if it fluctuates a little bit, don't worry about it too much. And once you have it settled at 0, you can then play your music, and then from time to time maybe just check it out. The voltage will fluctuate on how the 5 volt and minus 5 volt are depleted. The lower they go, you start to see a bit of a rise, so it will fluctuate a little bit. So that's why it's ideal to have the UC Pure Mark III that charge between songs, and this way you can keep that fluctuation to a minimum. Like I said, I've run it with 2.3 volt on the DC offset. It sounds fine, no problem. I'm running a $20,000 Macintosh C1100 here, so it handled it fine. But if you do have an amplifier that seems to react badly to DC, then you might, that would be the ultimate solution, is to put a capacitor in between them. Not my preferred way, but it could be your only way. But I've rarely seen an amplifier that kind of really malfunctions in those kind of conditions. But nevertheless, try it first on your own amplifier, and try it on a cheap amplifier first to make sure the first time it's running. once it's running fine, just to make sure you didn't, solder something wrong and suddenly you've got 15 volts here. Also measure so you see exactly what's going on. So let's measure the other side out of curiosity. We're going to flip those around. And we're just going to measure the other side out of curiosity just to see how it measures. And it's measuring 0.36 volts, so let's adjust that. Now, something to keep in mind, if you power the DAC first and then as a streamer, you are going to have 2.3 volt right off the bat at the beginning. So don't be surprised. This happens if you haven't played anything yet on your DAC. So the preferred way would be to power the streamer first, play something, and then power your DAC after. Now, if your amplifier is fine with DC, then don't worry about it too much. Whatever happens, eventually you're going to play something, it's just going to zero itself. Once you have it set, it's going to go back to that settings. But for some reason, when you first play, if you start with the streamer then the DAC, you will get a bit of voltage if you haven't played anything yet, because the DAC haven't really seen and haven't clicked into mode yet. The good thing is the maximum voltage you should get out of here is 2.3 volt, so you're still within the tolerance of most amplifiers in that 2 volts up and down gyration. But you definitely, once you start playing music, you want that to be close to zero as possible. Somewhere in the 200-300 millivolts, you'll be fine. Please note that the DC offset thing is a TDA chip thing. It's not part of the it's not part of the IV. It's not part of the IV stage, the amplifier stage, and it's just the TDA will produce a bit of voltage. The amplifier will amplify it, and that's how you get to up to 2.3 volts at the end. And like I said, everybody can do the things differently. If someone wants to put capacitors, they can put capacitors. You simply take those jumpers out, and now you have no more DC offset. You use your capacitors, and you're good to go as well. So you have options. This board can be configured in any way you like. You don't have to use it the way I have it set up, but this is my preferred configuration, and that's what I think where all the magic is happening. There will be a third video coming in a couple days as well on how to configure all the jumpers and all the different configurations that this board can run with. I highly recommend you use color-coded wires. I usually use black, red, and green. Red is plus, black is negative, and green is when you have 0 volts. So for example, for 15 volts, I would use this as 0, and this would be the 15 volts, so black and red. And for the plus 5 volt, I'll use red. For the 0, I'll use green. And for the minus 5, I'll use black. Use whatever color code goes into your brain and you're comfortable with, but using color-coded wire reduces the risk of accidentally wiring something wrong and basically burning, $500–600 worth of parts. The video about building the streamer portion, it's coming up, should be coming up tomorrow. So if you don't see it yet, just give it a little bit of time. And I'll put a link of it in the corner up here. And I'll put in the corner up here another video about how to build the +5 and -5 ultra capacitor power supply. There'll be a speaker in the middle. If you'd like to subscribe, I'll put a link to my Patreon if you'd like to join and get some extra tips and support. And I hope to see you guys in another video. Take care.